So moving on to the next question. It states that a man wishes to estimate the distance of a nearby tower from him. He stands at point A in front of the tower C and spots a very distant object O in the line with AC. He then walks perpendicular to AC up to B, a distance of 100 meters, and looks at O and C again. Since O is very distant, the direction BO is practically the same as AO. But he finds the line of sight of C shifted from the original line of sight by an angle theta degree is equal to 40 degrees. So the given theta is known as parallax. Estimate the distance of tower C from his original position A. Now, in this particular question, first let us understand what is parallax. Now, for this, you don't need to do anything. You can sit right where you are and have a look. So what I will do is, I will stick out my right hand with my thumb pointed up. Now, all of you can do this. So you close your left eye and look at the thumb with your right. Immediately close your right and look at the thumb with your left. Now this has to be placed exactly in front of you so that you can do this. So what do you notice is the important question here. Now, if let's say I have drawn this as your eye and this is the position of the thumb, when you have closed your left eye, so this is left, right. So when you have closed your left eye, your thumb appears here in this red spot. When you close your right and look through your left, it appears here. So what is happening? It is getting shifted. The reason is this point here, X, that is there, my initial point, that is our thumb, is sporting or giving us a very, very small angle, theta. Now this angle is called as the parallax angle. And this is very, very small compared to the distance in between our eyes, the center of our eyes. This distance is very small. That means the angular distance. So therefore, we get this. Now the same thing you can try with the sun. When you look at the sun is a spherical body. So you can eclipse the sun by just using your thumb, nothing else. So again, do the same thing. Close one of your eyes and take your thumb and align it in a position. So what you'll have to do is you'll have to take your hand front and back. So align it in such a position that it eclipses the sun. So this is possible using the idea of parallax. Now let us look exactly what is happening in this question. So for this, what we can do is we can go ahead and draw the diagram for this. So in drawing the diagram, you have to keep a couple of things in mind. First thing is, the distant object that is observed is O. So I'll put my distant object observed here, O. And this is in line with AC. So for AC, what we will do is we will draw one line. So the reason why I am not drawing exactly with O is because we are observing from B also. So what I will do, I will name this point as A, this point as C. Now, AC is perpendicular to B at a distance of 100 meters. So that means 100 meters away from point A, I will go ahead and draw point B. So 100 meters away means we can do it like this. So we'll draw a straight line which is moving like this. Okay, so this point I will name it as point B, and this I'm going to tell it as 100 meters. Now, and looks at O and C again. So that means looking at both O and C. So what I will do, since he's looking at O, I will draw one more line here. Well, this fixes it. So from A, O is observed. From B also O is observed. But looking at C. So what we will do is I'll use a different color. From B, I will draw the observational line to C. Now since O is very distant, the direction BO is practically same as AO. That means from A to O what observation happens, it happens from B to O also. But he finds the line of sight shifted from the original line of sight by an angle of 40 degrees. That means this angle that is there, as he is observing O, this angle is given as 40 degrees, or Since we can use geometry and take this as vertically opposite angle, this angle is 40 degrees. So for parallax, we always find tan of the angle. Tan theta is nothing but opposite by adjacent. So in this case, if we see, though we have 50 degrees here, we know that this is 40 degrees, what is given from our question. So since it is vertically opposite, so this is the opposite side, that is AB. So tan theta, I can take it as AB by AC. So tan theta is equal to AB by AC, or I have to find AC. AC will be equal to AB by tan theta, and AB we know it as 100. Tan theta is tan 40 degrees. Now 40 is not a standard angle. 40 degrees that is there is not a standard angle. So the value can be calculated using a Clark's table, a scientific calculator, or a log table. Here I will give you what is the value of tan 40 degrees. So tan 40 degree is equal to 0.8391. So when I substitute it here, I will get AC is equal to 100 by 0.8391, which will give me 119 meters. Now since we are measuring the length AC, it is going to be 119 meters.